with a new unit, and this unit's focus is going to be radicals. What you're used to being, what you know what a radical is, you're just used to square roots, okay? But it's ultimately called a radical, all right? And it's called a radical because that's like the basics. So like there's square roots, there's cube roots, there's fourth roots, there's fifth roots, those are all radicals. We just focus on square roots in Algebra 1. Okay, so with the square roots, there's these things called perfect squares, and we've kind of already talked about them. And perfect squares are just taking one number, squaring it, and the result of that is a perfect square. So I'm just going to list them all. So you have 1, you have 4, you have 9, 16, 25, 36, 49, 64, 81, 100, 121, and 144. So that's 1 squared, 2 squared, 3 squared, 4 squared, 5 squared, 6 squared, 7 squared, 8 squared, 9, 10 squared, 11 squared, and 12 squared. There's more. There's 13 squared is 169, 14 is 196, and 15 squared is 225. And I stopped there for a reason, because if I asked you what the square root of 25 is, you would tell me it's 15. And the reason it's 15 is because 15 times 15 is 225, and pairs come out of square roots. So pairs come out. I'm going to rewrite that. Oops. So that is the biggest thing you need to remember today. Pairs come out of square roots. Okay. So, you've done these before in probably last year, maybe, hopefully. So there's some assumption with these. So I'm going to show you these, except today we're going to be adding variables. So this is the method I use, and no, you don't have to use it. There's different ones. So what you're going to do is take 180, whatever number is in the radical, and I want you to divide it by a prime number. So prime numbers are like 2, 3, 5, and 7. And mainly you're going to use 2, 3, and 5. So I know 180 is even, so I'm going to divide it by 2, and that gets me 90, and I can divide by 2 again. That gets me 45. Well, 45 is not divisible by 5 or 2, so I'm going to go ahead and divide it by 5, and 45 divided by 5 is 9. And 9 is not divisible by 5 or 2, but it is by 3. And once you get to a prime number, you stop. So once you get to a prime number, equals stop. Okay, you stop at that point. Okay, so we're going to see what kind of pairs we have. Well, we have a pair here and a pair here. And we're left over with that 5. And I told you pairs come out of the square root. So this has a pair with 2. That 2 is just going to drop down. 2 is going to go here, and they're all multiplied, and that's a pair, so it goes to the outside. Whatever's not a pair goes to the inside, and that is this 5 right here. So these multiply together, you get 4 times 3, which is 12, and that is your answer. Okay, so another example, 54. We're going to go ahead and do this method. The 3 is just going to stay there, so I'm going to rewrite it. 54 divided by 2 is 27. That's not divisible by 2, so I wanted to use 3. Do 9 and divide that by 3, and you get 3. 3 is the prime number, so we stop. And this is a pair right here, but these two don't pair up with anything, so they stay on the inside. So on the inside, you have 2 times 3, and this is a pair, so it goes to the outside. So we have 9 square root of 6. Now you can enter this original in your calculator and then this simplified, and they should put out the same answer. Okay. So, moving on. It says right here, if there's a power, it goes in multiples of 2. So you take them out of groups of 2 or by pairs. So basically what you're going to do with the exponent is you're going to divide it by 2. And that's what goes to the outside. So we've actually already done this, and I've told you that a square root cancels out a square. But just to prove it, 2 divided by 2 equals 1, and that's why it becomes x to the first power, which would just be x. Okay. Number 2, we have a number in front, so I always say do the numbers first and then do the variables. Okay. So square root of 9 is 3. And we're going to take 10 and divide by 2, and that gets us 5 with no remainder. If there's a remainder, then something has to stay on the inside, but that's not the case. So it's x to the 5th power, okay? And it's x to the 5th power because there was 5 pairs made out of 10. Okay, number 3. So with number 3, and I'm just going to kind of show you this visually, we know x to the 5th power is the same thing as this. And I told you things have to come out in pairs. So that's a pair and that's a pair. And whatever doesn't have a pair stays on the inside. So this comes out as x, this time comes out as x, and this is stuck on the inside. So you have x squared square root of x. Well, just to prove it, if you take 5 divided by 2, it happens twice, and you'd have 1 left over, so a remainder of 1. 2 times 2 is 4, and then 1 would make it 5. And that's exactly how this looks. It's x squared square root of x with a remainder of 1. 2r2, right there. 2 radical 1, or 2r1, sorry. All right, I'm going to do number 4 and finish this video, and then I'm going to do another video and then another one, so just a heads up. So square root of 25, we know that's 5. So that's good. Then we look at the power, and we're going to divide that by 2, and we know that's 3. So we have x cubed, that's going to go to the outside. And then we have 13. And we're going to divide that by 2. Well, we know 2 times 6 is 12, so we can get 6 pairs out of it. But because it's odd, you're going to have that 1 left over. So you would have y to the 6th power, and then y to the 1st power on the inside, because that's what's left over. Okay. All right, so hopefully you are getting a hold of this a little bit. It's a little different. So go ahead and follow the next video. All right, see you then.